Bismillahirrahmanirrahim. Welcome back to my channel. Trying to start a new series called Basic Concept of Electronics, and we're going to start off with different type of resistors that we have, and we're going to try to measure some current and voltages and how you can measure current and voltages when you only have a single element called your resistors. All right, these are some of the common resistors that you normally see. You will see a resistor like this, which is commonly found. These are basically quarter watt resistors. Mostly, generally in electronics, most of the resistors are somewhere around quarter watt rated resistors. Then you got some fat ones. These are about 2 watts, and you got some even fatter ones like these. This is about 7 watt. Normally, for high power application, you will find resistors which are made out of ceramic, which looks something like this, and they are about, as you can clearly see, it says about rated for 5 watt, and it's about 100 ohms, and it says J in front of it. These are energy resistors. They are made out of ceramic. You can apply as much power as you want, and these are the same type of material that you will find normally in insulators that you have in power lines. Those brown insulators that you normally see, or your lighting arrestors are also made out of this type of a material, which is like sort of porcelain, ceramic, something like that, like porcelain, I would say. The cool thing about these resistors are, even though you apply high wattages, they will tend to create a smoke, and if you let it, like, if you stop providing voltage to it, it will cool down and it will come back to its normal rated resistance. That's the cool thing about these resistors. So this one is about 100 ohms. This one is about 5 watt, about 33 kilo ohms. Also have some, as you can see, this is about 10 watt, about 10 ohms energy resistor, because you have J in front of it. And then I got some other ones. This is about 100 ohms, and this is about 5 kilowatt, 5 watt, about 5 kilo ohms. 5.6 kilo ohms actually. You have 5k plus 6 ohms, so it's 5.6 kilo ohms energy resistors. So we're gonna learn how to make some measurements and how you calculate total resistance and things like that using breadboards. So we're gonna try to calculate power first of these resistors. So I'm gonna pick up one of these resistors right here, which is going to be a 100 ohms resistor. Is easy for me. Because as you can clearly see, I have my DC source and I have a limitation how much how much voltage I can provide using my my DC power supply. The maximum I can go about 31 plus 31 maximum voltage. So 31 plus 31, I can provide up to 62 volts DC. So that's why I'm going to choose to have a 100 ohms resistor. And based on this 100 ohm resistor, I'm going to do the calculation, some basic resistance, power, and wattage, voltage measurements. So this is rated for about 5 watt. So we're going to make some basic calculation, and we're going to try to verify using our multimeter and our DC source. So the definition of power is something like this. So power, electrical power, is defined by V over I. All right, and we know Ohm's law. Based on Ohm's law, we have Ohm's law, which is V is equals to IR. So if I want to calculate, because I know this is rated for about 5 watt, and how much current and how much voltage I need to provide in order for me to get 5 watt. So in place of this, so I'm gonna calculate my R, because I know I need to find out how much voltage do I need to provide to get 5 watt of power. So what I'm gonna do, once I move this around, so I is going to be V over R. All right. Then I'm going to input this value of I in the definition of power. So this would be P is equals to V times V over R. So this is going to be, power is going to be V squared over R. All right. These are some of the basic calculations that I need to do in order for me to find out that if I can use this resistor for 5 watts. All right. So the next thing I need to do is this. I know how much this resistor is rated for. So this is rated for by 5 watt. I know the resistance of my I know the resistor resistance, that is about 100 ohms. So I'm going to multiply both sides by 100. These are some basic calculations. So I will get about 500 is equals to V squared. And as we know, power is amplitude squared. So this is actually power. Power is amplitude squared. So now let's take a square root of both of these sides. Once I take a square root of 500, I will get 22.3 volts. This is going to be how much voltage do I need to provide for it to achieve 5 watt. All right, so this is, so from my DC supply, I'm going to apply 22.3 volts. That would give me a power of 5 watt if I have a 100 ohm resistor. So these are some of the basic calculations that I need to do. We're going to do some current calculation as well, because we're going to also measure some current as well. So current, as we know, V is equals to IR, and what type of a current I would expect from this resistor. So I know my voltage that I need to provide to achieve 5 watt is about 22.3 volts, and my current value that I need to find. So I'm going to move my R here, which is 100 ohms. So this is going to be 0.223. I was going to move 2 places. So it's going to 0.223 ampere. This is how much current I would see on my multimeter if I'm using a 100 ohm resistor that is rated for 5 watt. Anything more than this, start heating up this resistor, and eventually it will burn that. The cool thing about these energy resistors is they will not instantly burn. What will happen, you will start seeing the smoke coming out, and if you turn off your power supply, it cools down, it returns back to its original 100 ohm resistance. So let's make some of these measurements. 22.3, I'm going to use my DC supply to provide this, and we're going to measure 0.223 amperes using our multimeter. So having that aside, let's bring out our breadboard. It's just going to be a simple circuit. So I'm gonna just simply plug in into one of these wires. I will also make a video on breadboarding as well. I like these older design as compared to these newer ones, which is this, because the holes in this are quite small, and these high power resistors, they tend to have a fatter metal lead, so it's hard to insert in these boards. Now we're gonna make some few measurements before we do anything else. We're gonna take our multimeter, and we're going to measure, first of all, we're going to measure our resistance. In order for you to measure resistance, make sure you have your multimeter right here. Make sure it's connected to my volts, ohms, and continuity, and your COM port should be connected here. So if you don't know what your measurement is, what your resistance is, just leave it, move this knob to resistance, any of these, like let's say around 20k, and take your probes, put it on any end, because these are passive devices. So when you put it on any end, you start seeing some value, which means this value is too small to have it on 20k. So let's go to 2k and then measure. So this is about 100 ohms, but it's less than 100k. That's why you're getting a value in 0.10 value. Now let's take it to 200 ohms, and you're getting about 99.7 ohms. That's the value, because this is the maximum value you can achieve. When you have a knob like this is the maximum value you can achieve, and so on. So this is about close to 100 ohms, so which is good. I'm going to put this aside. I'm going to take my power supply. How much do I need? So I have it connected. I'm using only one part of the power supply. I can use it as an independent supply. I can use it as series and in parallel combination. I'm using it in terms of only series supply, and the maximum voltage that can come out, DC voltage, from this variable port is about 31.4 volts. So I'm going to change this to 22.3. Let's do 24. Okay, let's do 22.3. This much voltage is coming out. All right, from this port. Let me turn this power supply on. Make sure I have a maximum current. They are individually on. and I'm going to simply insert this part of my probe right here, and the negative part on this side. Now once I have voltages which is coming out to be 22.3, I wish I would have a thermal camera or something like that so I can show you that this element has started heating up. Then I'm going to take my multimeter, and since I'm making DC measurements, make sure I have this knob on DC value, and I know what value to expect. This is somewhere around 22.3, so I'm going to move this around. Not 20, this is the maximum you can get at this place, 20 volts. I'm expecting to see 22.4 volts because no other element is connected, and I'm going to simply put my probe across it, and look what I'm getting, 22.4, and this is exactly what I'm getting here. So 22.4, and right here when I connect this, this is what I'm seeing. I'm sorry, 22.4. This is what I'm seeing. Now let's quickly make current measurements. In order for you to make current measurement, because I'm working with 5 watts, I'm going to change this knob not to milliamperes but to 10 amperes. Up to 10 amperes I can get. Move this around, make this part of a circuit by doing what? Take this out, because for current measurement you have to make your multimeter part of a circuit. So this is going in like this. The positive is connecting to a positive probe. The negative is going to be on the other end. So I'm going to make this measurement, moving it to DC, and I'm going to put my probe here. Watch this. And I'm seeing 0.23, which I would expect to see. 0.223 or 0.23. This is how much current I'm seeing if I'm using a 5-watt resistor. So that's the basic idea how you will make measurements using multimeter. If you have any questions, leave it in a comment section, and don't forget to like and subscribe to my channel. And thanks for watching.